This challenge is contributed by one of our members, Seal, using Play's open source SDK. All these contributed challenges are openly accessible to community to try. This challenge is interesting because it embeds two quite unrelated security vulnerabilities in one app. So let me start it, and I will then run this challenge or run the app using the CDE, and we explore some of those misuse scenarios. I will use the familiar make commands here to run this app. Now, as we can see here, this app has an endpoint called view, and it has a parameter called image. And within the image, we can see it's a pass to a file name. So let me take that and try it. And we got the content of an image file that is hosted on that server back. Now, as we know, anytime we see there is a parameter that seems to point to a directory or a file name, we could try one of these misuse scenarios to see if we can read any other arbitrary files on that server. So one of the things we can try here is to try to go a couple of directories back or traversing to the parent directory and try to read any other arbitrary file. Now here I'm pointing it to etc passwd. The main reason being etc passwd, it's a common file on the majority of the Linux systems. And by traversing back as much as I want, and one thing about that traversing back is that you can traverse back as much as you want. Once it reaches the root of that file system, it will not go back. So let me try this payload. Well, it seems like it didn't work. However, if we look at the source page, there is something interesting here. The content of those image file or any file that we point at has written as in a base 64 format. So I have a suspicion that that content we see here is in fact the content of the passwd, however is base 64 formatted. Okay, let me just copy this and open the web console, and I will use a JavaScript method a2b to decode this. And as we can see, in fact, this is the content of the base 64. You may have noticed that the content of that image file was added to an image tag on that HTML source. So this will bring us to that second vulnerability in this app. What if instead of this /payload, I'll get rid of it, and I try to close that image tag using a quote and a smaller than sign, following with a script tag? Would that get executed? Well, as we can see, that JavaScript code got executed. So here we go. We got cross-site scripting also as part of this app. Now, the interesting part here is that we can use one security measure or defensive programming principle to address both of these security issues at once, which I will leave it to you.